Alright, yesterday we focused our attention on vertical shifts and stretching our graph. Today we're going to focus on changing the period and lateral or horizontal shifts. So remember your period. To find the period, you take 2 pi and you divide it by the absolute value of b. The interval, you take whatever your period was and you divide that by 4. Remember, the interval is the horizontal distance on the tick marks. Your amplitude is the absolute value of A, and that is going to stretch out your graph, or stretch it in, I guess you would say. And A, that A value, is going to determine the orientation and the stretching, which is the amplitude. So remember, if the amplitude is negative, it's going to reflect. So if cosine normally starts at the bottom, it would start at normally starts at the top, it would start at the bottom. Sine normally goes up and then down, down. Instead, it would go down, up, up. K is your vertical shift, and H is your horizontal shift. Because H is going to fall inside of those parentheses, remember, it is the opposite of what you think. Anything inside of parentheses or any grouping symbol is always going to be the opposite. So we look at our very first one here. We have that our graph is y equals 4x. So when we look at our general formula, our a is going to be equal to 1. Our b is equal to 4, and we don't have any other shifts. So our period is 2 pi divided by 4. Our period is going to be pi over 2. The interval, we take that and we divide that by 4, which is going to give us pi over 8. Make sure that you know how to divide within a fraction. Our amplitude is just going to be 1. There was no lateral shift and no vertical shift. So when we set this up, we still are going to have the 4 pieces. But this time, instead of going by pi over 2, we go by pi over 8. So 1/8 plus 1/8 is 2/8, which reduces down to 1/4, plus 1/8 gives us 3 pi over 8, plus 1/8 is 4/8, which is going to be pi over 2, which we know is going to be represented by one of our periods. Same thing in our other direction. So we've got a negative pi over 8, a negative pi over 4, a negative 3 pi over 8, and a negative pi over 2. And that was our only change. Our amplitude is 1. So I know that I'm going to go up to 1 and down to a negative 1. We have a sine graph. Remember, sine graphs are going to start at 0, 0. Then they go up, down, down, up. That is going to represent one of your cycles. We go down, up, down. That's going to represent your second cycle. Remember, we always circle where our starting point was. You always have the top, the middle, and your lower. You go up until you hit the top, and then you bounce back down, and once you hit the bottom, you bounce back up. And this would continue forever on and on in both directions. Now you might be thinking, okay, this looks exactly the same as y equals sine of x. It doesn't look any different. Now if I were to look at what it was before, normal without a shift, our period was at 2 pi. And a normal sine graph is going to go 0, up, down, down, up. So this would be the graph of y equals sine of x. What we did is we changed the period. So instead of going from 0 to 2 pi, we're only going to pi over 2. So now that's our new, starting at 0, up, down, down, up. So even though you can't really see it, because we make our own scales and it looks the way you set it up. So I could have made my 1 here, my 1 there, and then it's going to look really, really, low. But they are generally the same, except for the distance it's covering. One cycle is going to change. Normally it goes to 2 pi. Now one cycle only goes to pi over 2. That was the only change that was made. Okay, let's go ahead and look at our next one. We see that we have an a value of 1, a b value of 4, and because this is inside, we have a horizontal shift. Our h is going to be equal to pi over 8. Remember, it's the opposite of what you see. So our period is 2 pi divided by 4, so it's going to give us pi over 2. We cut that into 4s, and we get that our interval is going to be pi over 8. We found that our amplitude is 1, so the vertical distance between is just going to be 1. Our lateral shift, since it's going to be opposite of what we see, it's going to be right pi over 8, and we have no vertical shift. So go ahead and set up your graph. Alright, so we have really 2 changes here, our b and our h. The b is going to change our period, the length of one of our cycles, and that change is only seen with how we label our numbers on the x-axis. Our other shift is we're going to go right pi over 8. Generally, a sine graph starts at 0, 0, goes up, down, down, up. But because of that lateral shift, we're going to start right pi over 8. So we normally would start at 0, 0. Now we're going to start at pi over 8, 0. And then we go up, down, down, up. So we actually have to add right here. So we have 1/2 plus 1/8, which is going to put us at 5 pi over 8. And that's going to represent our 1 cycle. So then we have to go down, up, up, down, and that's going to represent our 2nd cycle. Remember what we talked about yesterday, you should have 5 points in each cycle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Each cycle is going to share that 1 point. Don't forget you always have an upper limit, a middle, and your lower limit. So you should only have points on 3 different levels. Okay, our next one. We've got cosine of x plus pi over 2. I want you to press pause and try this one all on your own. Okay, let's see how you did. We found that the a value is 1, b was also 1, so the only change we had was our h. So the only change we had was that the lateral shift, we were going to go left pi over 2. I want to make sure that when you are describing your lateral shift and your vertical shift, you're not saying positive, negative. You're actually indicating direction. So if you were to mark negative pi over 2, you would be marked wrong. Make sure that you tell the direction that the negative means it's going to go left pi over 2. We didn't have a shift in our period this time, so it's just 2 pi and pi over 2. And remember, the period and the interval can be seen in your labels on your x-axis. The amplitude was 1, which again just means the distance between your vertical distance between your points. And so normally we think about our general cosine. So in the black or in the gray dotted line, that's a general cosine graph. It normally starts up at 1, and the amplitude of 1 goes 1, down, down, up, up, down, down, up, up. But because we had a lateral shift, that starting point got shifted to the left pi over 2. So I had to go that distance, then we had to go down, down, up, up. So I had to add an extra point on my x-axis. We are going by 1/2, so now I'm at negative 5 pi over 2. Down, down, up, up. Okay, so let's go ahead and flip on over to that back page. Our next one here, we see that our a value is equal to 1. Our b is equal to 1/2, and we have an h of pi. So our period is 2 pi divided by 1/2, which is going to be 4 pi. Again, make sure that you can divide correctly with fractions in your calculator. Your interval, we take that period, we divide by 4, so we get that each horizontal distance is going to change by pi. Our amplitude is 1. Our lateral shift, we are going to go right by pi, and there aren't any vertical shifts. So go ahead and just set up your axes. Okay, you can see the gray dashed equation graph is that of a general sine graph. A general sine graph starts at 0, 0, goes up, down, down, up. And you have your amplitude of 1. When I look at this, the only thing that shifted was our period, and you can see that in our labels on our x-axis and our interval. So that was all taken care of in labeling. Our amplitude is still 1, so for distance between is a distance of 1. Our lateral shift is that we are going right pi. So we normally were starting here. We have to move that a distance of pi. So this is my new starting point, and then I have to go up, down, down, up. Got to add on that 5 pi, but I still have the same shape. I've just shifted it to the right. So then this is going to be down, up, up, down. I have that exact same shape in my graph. Again, the whole graph itself is just going to be shifted to the right by a distance of pi. Okay, we have 2 more left. Our next one is a great example because it's different than anything we've seen so far yesterday or today. We do see that our a value is 1, but when we look at the general form of the equation, we have y equals a times sine of bx minus h plus k, where that b value is outside and your x always has a positive 1 coefficient. So what we have to do is we have to rewrite this so that this 1/2 comes outside those parentheses, which means we have to divide each of those terms by 1/2. So we've got y equals sine of 1/2. It's easy, when I pull 1/2 out of that, I'm left with just x. Now the hard part is we have 1 divided by 1/2. 1 divided by 1/2 leaves you with 2 pi. Again, it is very, very important that you are able to divide with fractions. So we pull that 1/2 out. When I put it in, I multiply. So when I pull it out, I have to divide. So that gives us our b value of 1/2. It's inside, so we're going to have an h value of 2 pi and no vertical shift. So we take our 2 pi, we divide by 1/2, and we end up with our period as a pi. So we take that, we divide that by 4, which means our interval is going to be by pi. Our amplitude is still 1. Our lateral shift is that we are going to go right 2 pi, and our vertical shift is none. So go ahead and take your information and set up your graph. You can draw in your regular sign if you would like. Okay, so our period was 4 pi, our interval was pi, so when I labeled, I went by pi's all the way to 4 pi, showing me 1 cycle. The amplitude was 1, so our distance between each point, a vertical distance of 1. We have a lateral shift of 2 pi, no vertical shift. So generally I start at 0, 0, but I have to move that starting point 2 pi to the right, which means this is now my new starting point. So then I have to go up, down, down, up. So I actually have to add 2 more. So this is 5 pi and this is 6 pi. So down, up, up, down. Again, don't forget to make sure that you are circling your starting point so I can see where your shifts have taken place. And again, just like every other graph, you have your upper bound, your middle, and your lower bound. You have those 3 levels, and your points will only fall on those 3 levels. So we took our sine graph, we changed the period, and then we went ahead and moved it right 2 of our interval spots. We went 2 pi to the right. I know you are very excited here. We have one last graph. As we look at our last graph, we see that our a value is a -3. As soon as I see that -3, I'm going to put a star and I'm going to remind myself to flip so I don't forget about that. Now my b is stuck inside there again, so I have to rewrite that equation. Y is equal to a -3 cosine. I bring that 2 out. It's easy. 2x divided by 2 leaves me with an x. When I have 1 divided by 2, I am left with 1/2. So that's pi over 2 minus 1. So we have that our b value is 2. We have a horizontal shift of -2, or pi over 2, and we have a vertical shift of -1. Remember, inside is the opposite, outside is exactly. So we take our period, we divide that by our b, so our period is going to be pi. We divide that by 4, so each tick mark is going to be pi over 4. Our amplitude is 3. Our a value is -3, but the amplitude is the absolute value of that, so it's a +3. Your lateral shift is the opposite, so we are going to go left pi over 2, and our vertical shift is where you're going to go down a -1. Just like before, go ahead and press pause, set up your labels on your axes, and if you want, you can go ahead and draw your general cosine graph. Okay, so we have our period and our interval taken care of, and the label on our axes. We have a general cosine graph starting at 0, 1, going down, down, up, up, down, down, up, up. Now we have several changes to go on here. Every single possible change that we could have, we have. We've taken care of period and interval. Now we have amplitude. Amplitude means we're amplifying it by that factor. So 1 times 3 now puts us at 3, because 1 times 3 is 3. But we also have a negative, which means I have to flip it. So now it's really at a -3. But I still have 2 more shifts. I have to go left pi over 2, so I have to go left 2 spots, and then down 1. So my real starting point is there. So let's do that one more time. We have an amplitude of 3, so 1 times 3 is 3. Because our a value is a negative, we have to flip it. We have to reflect it along that x-axis, putting us at a -3. Then we have to shift left pi over 2, which is 2 of our marks, and then down 1. We have 2 choices here. You can follow the cosine pattern, or you can move and shift each of your points. So if I hear it, we're at 0, I multiply by 3, which is still 0. I flip it, which is still 0, but then we have to go left pi over 2, so we have to go left 2 spots and down 1. That would give me my next point. Or, so we could shift each of our points, or you could remember that cosine is generally the top of the graph. So that's our top of our crest. However, because we had to reflect it, it's now the lower end of our graph. Our middle, we have an amplitude of 3, which means our vertical distance between our points is 3, which means if I'm at -4, I go up 3, 1, 2, 3. My middle is going to be at a -1, which we did find when we shifted our second point. Now we have to go up 3 more, 1, 2, 3. So the top of our graph is going to be at a +2. Again, the amplitude shows us the distance between our points vertically. The interval shows us the distance between our points horizontally. So I could just follow my pattern. I have to go up until I hit, and then I bounce back down, making sure that I'm on those 3 levels. So there's one, oh that's really bad, one cycle. Man, I cannot draw my graphs today. That will have to do. And then it would bounce back up. Over here, we would have to go up, up, down, down. So I actually have to add 2 more points on here. We're going by 1/4, so this is -5 pi over 4. And then this one, we add 1 more fourth, or subtract 1 more fourth, which would be 6/4 which would be -3/2. Again, we have those 5 points that would be bouncing back up because we're at the bottom. And there is your graph of everything flipped or put in together, including a negative amplitude giving us our flip. And now we are done.